in this lecture we'll find out the area of the shaded region. In the drawing we have three semicircles. This is the big semicircle that contains those two smaller semicircles. We know that the radius of this semicircle equals to 2 units in itself. The radius of this semicircle equals to 1 unit in itself. And our test is to find out the area of this shaded region. So first of all, we define the center of the biggest semicircle. The big semicircle, this point is point O. And define the center of this semicircle. This point is point P. And define the center of this semicircle. This point is point Q. AB is the diameter of the big semicircle, and AB is a tangent. It is also a tangent to the circle at this point. So we define the point of tendency of tangent AB with this semicircle. This point is point M. And we define the point of tendency of tangent AB with this circle. This point is point N. We define the touching point between those two semicircles. This point is point T. Those two semicircles have an external knot between them at point T. That is to say, they touch each other externally at point T. And whenever you have an external knot between two circles or semicircles, you can implement Rule 10. So quickly on Rule 10. According to Rule 10, if two circles touch each other externally, then the straight line that connects their centers together passes through their touching point. And now we have two circles. Those two circles touch each other externally at point P. The center of this circle is here at point O. The center of this circle is here at point M. The straight line that connects the centers together is of course the straight line OM. And according to this rule 10, the straight line OM must pass through their touching point, that is point PO. The straight line OM must pass through point P, that is their touching point. Or OPM is one straight line. Again, OPM is one straight line according to this rule 10. So we can actually implement rule 10 in our drawing. Why? Because in our drawing, those two semicircles touch each other externally at point T. Point P is the center of this semicircle, point Q is the center of this semicircle, and according to Rule 10, the straight line that connects the center, those two centers together, the straight line PQ must pass for point T, that is their touching point, or PTK is one straight line. According to Rule 10, PTK is one straight line. So we join points P and Q together by straight line, and according to Rule 10, the straight line PQ must pass through point T, that is their touching point. So indeed, from the morning it is very easy to see that the straight line PQ that connects the centers of those two semicircles together indeed passes through point T, that is their touching point. And therefore, PQ in total must be equal to PT plus TQ. Again, PQ in total must be equal to PT plus TQ because of the fact that PTQ is one straight line. PT is the radius of this circle, equals to 2, according to what's given in the equation. PQ is the radius of this smaller semicircle, equals to 1. Again, PQ in total equals to PT plus TQ. In total, PQ equals to PT, that is 2, plus TQ, that is 1. So in total, PQ equals to 2 plus 1, that is 3. So PQ equals to 3. And now PQ equals to 3 according to rule 10. So we have here quadrilateral PQ and M. We can implement here rule 1. The radius PM that equals to 2, the radius PM is drawn to point M, that is the point of tendency of tangent AB with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MP. If AB is perpendicular to MP, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1, of course. Likewise, tangent, the radius QN that equals to 1, the radius QN is drawn to point N, that is the point of tendency of tangent AB with this small semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NQ. If AB is perpendicular to NQ, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to the same rule, rule 1. So in the next step, I'll copy quadrilateral PQ and M in a new page and analyze this quadrilateral. You know that PQ, side PQ of quadrilateral PQ and M equals to 3 units in its length according to rule 10. QN is the radius of this circle equals to 1, and PM is equals to 2. It is the radius of this semicircle equals to 2. So MN is the only side that is missing in quadrilateral PQ and M. Those two angles inside the big quadrilateral, this big quadrilateral PQ and M are right angles according to rule 1. Again, PM equals to 2 units in its length. It is the radius of this semicircle. And QN equals to 1. So actually, this is quadrilateral PQMN that I copied from the original drawing. So in the next step, we will do a construction, that is to say from point Q, from the vertex Q of this quadrilateral PQ and M, we will go perpendicular on PM. Again, from the vertex Q, we will go perpendicular on PM. So So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point Q inside PM. This point is point L. So by doing this construction, create smaller quadrilateral. This is quadrilateral L, Q, and M. In this smaller quadrilateral N, Q, and M, we have 1, 2, 3 rectangles. And therefore, this fourth missing must be equal to 90 degrees in its size, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. So, in the small quadrilateral L, Q, and M, we have 4 rectangles, and therefore it is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So, this rectangle L, Q, and M, side QN equals to the opposite side LM, but QN is 1, therefore the opposite side LM must be also equal to 1 unit in its length. So, what is the length of this missing line 7 PL? From the drawing, it is very easy to see that PL in total equals to PM minus LM. Again, PL minus LM equals to PL. So write it down. The missing side PL is equal to PM minus LM. So PL equals to PM. PM is 2. It is the radius of the bigger semicircle. It equals to 2 minus LM. We just write down that LM equals to 1. So PL in total equals to 2 minus 1, that is 1. So PL equals to 1 unit in its length. So in the next step, we will implement the Pythagoras theorem on this right triangle PQL. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So, in the right triangle PQ, right green triangle PQL, here by PT is abbreviation for Pythagoras theorem. So in this green right triangle PLQ, PQ squared, that is the square of the hypotenuse, is equal to PL squared plus LQ squared. Okay. PQ is 3, therefore PQ squared is 3 squared, that is 9. And it is equal to PL squared. PL is 1, therefore PL squared is 1 squared, that is 1. Plus LQ squared. LQ is the missing side, so leave it as it is. So in total, we found out that 9 equals to 1 plus LQ squared. Here we subtract 1 from this equation, and finally we get that LQ squared, that is the missing side, equals to 9 minus 1, that is 8. LQ squared equals to 8. Here we take out of this equation, and finally we get that the missing side LQ is equal to the square root of 8 units in its length. Substitute 8 by 4 times 2. The square root of 4 is 2, so inside the root we left only with 2. So in total we found out that LQ equals to 2 times square root of 2 units in its length. This is side LQ. That equals to 2 times cot of 2 units in its length. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle, LQ and M, side LQ must be equal to the opposite side MN, but LQ is 2 times cot of 2, therefore MN must be also equal to 2 times cot of 2 units in its length. So we actually found out that this is a line segment MN or side MN that equals to 2 times cot of 2 units in its length. We define the length of this line segment MOSA. So what is the length of this missing line segment ON? ON equals to MN minus MO. So write it down. ON equals to MN minus MO. ON equals to MN minus MO. Okay. ON equals to MN minus MO. So ON in total equals to MN is 2 times cot of 2 minus MO. MO is A according to our definition. So in total, we found out that the missing line segment ON is equal to 2 times cot of 2 minus A units in its length. This is the missing line segment ON is equals to 2 times cot of 2 minus A units in its length. In the next step, we will join points O and Q together by straight line. Okay, again, we join points O and Q together by straight line. Point O is the center of the biggest semicircle, and we have here chord EF. What is the length of EQ? Point Q is the center of this semicircle. Point E is the point of the semicircle itself. Therefore, Q is the radius of this semicircle. That is equals to 1. So EQ equals to 1. Likewise, point Q is the center of this semicircle. Point F is the point of the semicircle itself. Therefore, QF is also the radius of this semicircle. That equals to 1 according to what is given in the question. So actually, did from the center of the biggest semicircle, we draw from point O, that is the center of this biggest semicircle, we draw line segment OQ on chord EF. Again, from point O, that is the center of this biggest semicircle, we draw line segment OQ on chord EF. Chord EF has been bisected into 2 halves. EF in total equals to 1 plus 1, that is 2, so at point Q, line segment OQ bisected chord EF into 2 halves. Each half, of course, is equal to 1, because EF in total is 2. So you can implement here rule 30. Repeat quickly on rule 30, according to rule 30, a line segment that is drawn from the center of a circle and bisect the chord will be also perpendicular to that chord. So, in the drawing, we have a circle. This is point O, that is the center of this circle. From point O, we do bisected, this is called AB. From point O, line segment OM bisect chord AB. Again, line segment OM bisect chord AB. That is to say, AM equals to MB. Again, from the center of this circle, we have line segment OM that bisect chord AB. AM equals to MB. So, whenever you go from the center of the circle, a line segment that bisects any chord, the line segment that bisects the chord will be also perpendicular to that chord. Line segment OM bisects chord AB, and therefore line segment OM must be also perpendicular to AB. OM is perpendicular to AB according to this rule, rule 30. So whenever you have a line segment that is drawn from the center of the circle and bisects a chord, it will be also perpendicular to that chord. OM is bisect chord AB, and therefore OM is also perpendicular to AB. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 30. So we can definitely implement rule 30 in our drawing. Why put in our drawing? From the center of the biggest semicircle, that is actually point O, we draw a line segment OQ that bisects chord EF. Again, OQ bisects chord EF. Why? Because EF in total equals to 2, and OQ bisects chord EF into 2 halves. Each half equals to 1. EF equals to 1, and QF also equals to 1. And according to rule 30, whenever you have a line segment from the center of the circle that bisects the chord, it will be also perpendicular to that chord. So according to rule 30, line segment OQ is perpendicular to EF. So according to rule 30, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay. So in the next step, we'll join points O and E together by a straight line. Point O is the center of the biggest semicircle. Point E is the point of the biggest semicircle itself. Therefore, OE is the radius of the biggest semicircle. We define the radius of the biggest semicircle as x. Therefore, OE equals to x. So, in the next step, we will implement the Pythagoras theorem on this right triangle EQ. If I repeat again, we will implement the Pythagoras theorem on this right triangle EQO. EQO. Here by PT is the abbreviation for Pythagoras theorem. So this is the right triangle EQO. This right triangle EQO. EO squared, that is the square of the hypotenuse. Equals to EQ squared plus QO squared. And again, in this right triangle EQO, according to the Pythagoras theorem, the following equation is true. That e all squared, that is the square of the hypotenuse, equals to eq squared plus q all squared. The hypotenuse EO is the radius of the biggest semicircle, that is x. Therefore, EO squared is x squared equals to EQ squared. EQ is 1, therefore EQ squared is 1 squared, that is 1, plus QO squared. QO is the hypotenuse of the right triangle QNO. Therefore, according to the Pythagoras theorem, we'll implement the Pythagoras theorem on this right triangle QNO. According to the Pythagoras theorem, QO squared is the square of the hypotenuse of this right triangle QNO equals to QN squared plus NO squared. So in total, we found out that according to equation 1, x squared equals to 1 plus qn squared plus no squared. Okay, again, qn is one side of the right triangle QNO, but qn is also the hypotenuse of this right triangle E and Q. And therefore, if we focus on this right triangle E and Q, QO squared will be equal to qn squared plus NO squared. Again, QO squared equals to qn squared plus NO squared. So in total, x squared equals to 1, that is EQ squared plus QO squared equals to QN squared plus NO squared. So, according to equation 1, x squared equals to 1 plus qn squared. Qn is 1, therefore qn squared is 1 squared, that is 1, plus no squared, plus on squared. On squared is 2 times square root of 2 minus a, therefore on squared is 2 times square root of 2 minus a squared. So again, we found out that x squared equals to 1, and we have qn squared. Qn is 1, therefore qn squared is 1 squared, that is 1, plus on squared. On equals to 2 times square root of 2 minus 2, therefore on squared equals to 2 times square root of 2 minus 2 squared. So here we open the brackets of this expression, and again that according to equation 1, x squared equals to 1 plus 1 is 2, plus, here we have 2 times square root of 2 minus 2 squared. It is equals to 2 times square root of 2 squared, that is actually 8, plus a squared minus 2 times 2 times square root of 2 times a. Here, n all equals to 2 times square root of 2 minus a, not minus 2 but minus a. Okay, so it is n all square equals to 2 times square root of 2 minus a square. And therefore 2 times square root of 2 square equals to 2 times square root of 2 square, that is 8, plus a square minus 2 times square root of 2 times a. So in total, according to equation 1, we found out that x squared equals to 2 plus 8 is 10, plus a square minus 2 times 2 is 4, so in total this expression equals to 4 times square root of 2 times A units. So in total, according to equation 1, we actually found out that x squared equals to 10 plus A squared was 4 times square root of 2 times A times A. This is according to equation 1. In the next step, we join points O and P together by a straight line. And we join points O and C together by a straight line. Point P is the center of this semicircle. Point Q is the point of the semicircle itself. Therefore, CP is the radius of this semicircle. This goes to 2. Likewise, point P is the center of this semicircle. Point D is the point of the semicircle itself. Therefore, PD is also the radius of this semicircle. Equals to 2. So what we have in the drawing we have from the center of the biggest semicircle, that is to say from point O, we do line segment OP that bisects called CD. Repeat again. This is called CD. This is called CD, that has been bisected by line segment OP. Again, from the center of the circle, that is to say from point O, the center of the biggest semicircle, we draw line segment AP, line segment OP that bisects chord CD. And according to rule 30, if we draw from the center of the circle line segment that bisects the chord, it will be also perpendicular, the line segment will be also perpendicular to the chord. OP bisects chord CD because CP equals to PD equals to 2. And therefore, line segment OP must be also perpendicular to CD. OP is perpendicular to CD, according to rule 30. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 30, because of the fact that from the center of the biggest semicircle, we have line segment OP that bisects chord CD. Therefore, according to rule 30, line segment OC must be also perpendicular to CD. So in the next step, we'll implement the Pythagoras theorem on this right triangle CPO. Here by PT is abbreviation of Pythagoras theorem. According to the Pythagoras theorem, in this right triangle CPO, C of course is the radius of the biggest semicircle that is equals to x. CP equals to 2, and PO is the only missing side in the right triangle CPO. So in this right triangle CPO, according to the Pythagoras theorem, CO squared, that is the square of the hypotenuse, is equal to CP squared plus p all square. And again, in this side I can see p all according to the Pythagoras theorem. C all squared, that is the square of the hypotenuse, equals to cp squared plus p all squared. CO is x, therefore CO squared is x squared. And it is equals to cp squared. Cp is 2, therefore cp squared is 2 squared, that is 4, plus p all squared. PO is the missing side. PO is one side of the right triangle COP. But PO is also the hypotenuse of this right triangle PMO. Again, PO is also the hypotenuse of this right triangle PMO. According to the Pythagoras theorem, PO squared, that is the square of the hypotenuse of this right triangle PMO, equals to PM squared plus MO squared. And again, in total, I should find out that CO squared equals to CP squared plus PO squared. CO is x, therefore CO squared is x squared, plus, and it is equals to CP squared. CP is 2, therefore CP squared is 2 squared, that is 4, plus PO squared. So, okay, again, that PO is the hypotenuse of this right triangle PMO, so PO squared, that is the square of the hypotenuse, must be equal to PM squared plus MO squared. PO squared equals to PM squared plus MO squared. Implement the Pythagoras theorem on this right square triangle. So now I should find out that according to equation 2, x squared equals to 4 plus PM squared. PM is 2, therefore PM squared is 2 squared, that is 4, plus MO squared. MO is 8, therefore MO squared is 8 squared. So today, according to equation 2, if we found out that x squared equals to 4 plus a squared. So according to equation 2, we should find out that x squared equals to 4 plus 4 is 8 plus a squared. So in total, according to equation 2, we should find out that x squared equals to 8 plus a squared. While according to equation 1, we only found out that x squared equals to 10 plus a squared was 4 times 2 times a. So we have two different equations for x squared. So in the next step, we create equation 3 that says that x squared according to equation 1 must be equal to x squared according to equation 2. So equation 3 says that x squared according to equation 1 must be equal to x squared according to equation 2. And again, according to equation 3, x squared according to equation 1 must be equal to x squared according to equation 2. X squared according to equation 1 equals to 10 plus a squared was 4 times square root of 2 times a, and it must be equal to x squared according to equation 2. X squared according to equation 2 equals to 8 plus a squared. The total according to equation 3, we actually found out that 10 plus a squared was 4 times square root of 2 times a equals to 8 plus a squared. Here we have a squared on both sides of the equation, so a squared gets cancelled. Here we subtract 8 from this equation 3, and finding that, so in this side of the equation we have nothing, that is to say 0. While on the other side of the equation we have 10 times 8 is 2. So in total, on this side of the equation we have 2 minus 4 times square root of 2 times a equals to 0. So here we write 4 times square root of 2 times a to this equation, and finding that according to equation 3, 2 equals to 4 times square root of 2 times a. According to equation 3. So here we divide this equation 3 by 2, and finding that 2 times 2 is 1 equals to 4 times 2 is 2. So in total this expression equals to 2 times square root of 2 times a. So according to equation 3, 1 equals to 2 times square root of 2 times a. So here we divide this equation 3 by 2 times square root of 2. And we get that according to equation 3, a equals to 1 over 2 times square root of 2. So found out the value of a equals to 1 over 2 times square root of 2. Well, according to equation 2, now we found out that x squared equals to 8 plus a squared. X squared equals to 8 plus a squared. According to equation 2, x squared equals to 8 plus a squared. A is 1 over 2 times square root of 2, therefore a squared must be equal to 1 over 2 times square root of 2 squared, that is 1 over 8. So in total, according to equation 2, I shall find out that x squared equals to 8 plus 1 over 8. So x squared equals to 1 over 8 plus 8. So here we multiply 8 by 8 and then we divide it by 8 in order to a common factor with this number. So 8 times 8 is 64. Then we divide it by 8, so we change nothing. So in total, x squared equals to 64 plus 1 is 65 over 8. Total, we found out that x squared equals to 65 over 8 units. X squared equals to 65 over 8. Actually, the square of the radius of the biggest circle, the biggest semicircle. The radius of the biggest semicircle is x, therefore x squared is the square of the radius of this biggest semicircle. So actually finished to answer the question, because we know that the radius of the biggest semicircle is x, the radius of this semicircle is 2, and the radius of this semicircle is 1. So what is the value of the shaded area? From the drawing, it is very easy to see that the value of this shaded area equals to the area of the biggest semicircle that contains the smaller semicircles. Minus the area of the right circle, right semicircle, minus the area of the left, of this left semicircle. Repeat again. the area that we are looking for this question, that is the value of the shaded area, total is equal to the area of the biggest semicircle minus the area of the right semicircle minus the area of the left semicircle. If you subtract from the area of this biggest semicircle those two areas, it's very clear that what is left is the shaded area. Okay? Therefore, the value of the shaded area equals to the area of the biggest semicircle minus the area of those two semicircles. Very simple. Okay? What is the area of the biggest semicircle? Equal pi x squared over 2. X is the radius, therefore it is equals to pi x squared over 2. And again, the area of this biggest semicircle, the radius is x, and therefore it must be equal to pi x squared over 2. Okay, minus the area of this right semicircle. The area of this right semicircle equals to pi r squared over 2. R is 2, so it is pi 2 squared over 2. Pi 2 squared over 2. The area of the right semicircle minus the area of the left semicircle, that is pi times 1 squared over 2. So in both in all the three expressions we have pi over 2, so we'll take pi over 2 as a common factor out of those three expressions. So pi over 2 is taken as a common factor from this expression, so all it is left from this expression after we took from it pi over 2 as a common factor, what is left is actually x squared minus we took pi over 2 as a common factor from this expression, so what is left is 2 squared, that is actually 4. We took pi over 2 as a common factor from this expression, so what is left is actually 1 squared, that is 1. So in total we found out that the area that we are looking for in this question, that is the value of the shaded area equals to pi over 2 times x squared minus 4 minus 1. This is pi over 2, and we already found out that x squared equals to 65 over 8, so we substitute x squared by 65 over 8. Minus 4 minus 1 is minus 5. So total, the value of the shaded area equals to pi over 2 times 65 over 8 minus 5. So here, so it is pi over 2. Inside the brackets we have 65 over 8. So here we will multiply 5 by 8 and then we divide it by 8 in order to have a common factor with this number. 5 times 8 is minus 5 times 8 is minus 40. So multiply it by 8 and then we divide it by 8, so we change nothing. So in total, the area of the green, the shaded area equals to pi over 2. We have 65 minus 40 is 25 over 8. So in total, we have in the numerator we have 25 pi. In the denominator we have 2 times 8, it is 16. So in total, we found out that the value of the shaded area equals to either 25 pi over 16 square units in inside, so in terms of numbers, is equal to 4.98 908 square units in size. Okay. And again, the value of this shaded area is equals to either 25 pi over 16 square units in size, or in terms of numbers, is equal to 4.908 square units in size. Okay, so in the next step of summer's lecture. In this lecture, I found out the value of this shaded area. So, in the drawing, we have 3 semicircles. This is the biggest semicircle that contains those 2 smaller semicircles. You know that the radius of this semicircle, radius r equals to 2, the radius of this semicircle is 1. Again, our task is to find out the value of this shaded area. So first of all, we define the center of this semicircle, this point is point P. We define the center of this semicircle, this point is point Q. AB is actually the diameter of the biggest semicircle, and AB is the tangent to the circle at this point. So we define the point of tendency of tangent AB with this semicircle, this point is point M. We define the point of tendency of tangent AB with this semicircle, this point is point N. So then we have PM, that is the radius of this circle, that is equals to 2, and QN, that is the radius of this semicircle, that is equals to 1. Here the radius PM that is equals to 2, the radius PM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MP. If AB is perpendicular to MP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, tangent AB is tangent to this semicircle at point N. The radius QN is equals to 1. The radius QN is drawn to point N, that is the point of tendency of tangent AB with this semicircle. And whenever your radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NQ. If AB is perpendicular to NQ, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to the same rule, rule 1. Point P is the center of this semicircle. Point Q is the center of this semicircle. Those 2 semicircles have an acceleration between them at point T. That is to say, they touch each other acceleration at point T. Whenever you have an acceleration between 2 circles, or semicircles, or quarter circles, you can implement rule 10. So I think quickly rule 10. According to rule 10, a line segment that is drawn from the center of a circle and bisect a chord will be also perpendicular to that chord. So, in the moment you have a circle, this is point O, that is the center of this circle. We have chord AB inside this circle. So, line segment OM bisect chord AB, that is to say, AM equals to MB. And now you draw a line segment from the center of the circle that bisects the chord, it will be also perpendicular to that chord. So line segment OM is also perpendicular to AB. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to this rule, rule 30. Actually, it is very easy to prove that line segment OM, whenever line segment OM bisects chord AB, line segment OM must be also perpendicular to AB. Why? Because those 2 triangles, they can go into each other according to side rule. OA and OB, they are both the radii of the circle, therefore they are equal to each other. OM is equal to itself, it's a common side that belongs to both triangles, and MA equals to MB because OM bisect chord AB. So all the 3 sides of this triangle AM are corresponding equal to all the 3 sides of this triangle OMB, and therefore those 2 right triangles can go into each other according to side rule. And from the fact that those 2 right triangles can go into each other, we find that those 2 corresponding angles must be also equal to each other according to the rule that corresponding angles between corresponding angles and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore those two corresponding angles must be also equal to each other in their sizes. So if the size of this angle is x, then the size of this angle must be also equal to x because they are equal to each other. But x plus x in total must be equal to 180 degrees because the sum of the angles from one side of a straight line is equal to 180 degrees. AB is a straight line. So the sum of the angles from the upper side of AB at point A must be equal to 180 degrees. So x plus x must be equal to 180 degrees. 2x equals to 180 degrees. We divide this equation by 2 and get that x equals to 90 degrees. So each angle is a right angle. So we prove here that whenever you have line segments from the center of the circle that bisect the chord, it must be also perpendicular to that chord. We prove that those two angles are both right angles. Okay, so according to Rule 30, whenever you have a line segment from the center of the circle that bisect a chord, then the line segment OM must be also perpendicular to that chord. OM is perpendicular to A, is perpendicular to AB. It means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, Rule 30. So we can actually implement Rule 30 in our drawing. Because in our drawing, we have from the center of the biggest semicircle, that is point O, we go line segment OQ. Line segment OQ definitely bisect chord EF. EF in total is 2. The first half EQ is 1, and the second half QF is also 1. Because above the radii of this semicircle equals to 1. So line segment OQ bisect chord EF. And therefore line segment OQ must be also perpendicular to EF. If OQ is perpendicular to EF, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to Rule 30. Okay. But we did it too early, before we proved Rule 30. Actually, we have to implement Rule 10. Okay, so we have those two semicircles have an acceleration between them at point T. Point P is the center of this semicircle, point Q is the point of the semicircle. Point P is the center of this semicircle, point Q is the center of this semicircle. The straight line that connects the centers together is of course the straight line PQ. And according to Rule 10, the straight line PQ must pass from point T, that is the touching point of PTQ is one straight line. Again, PTQ is one straight line according to Rule 10. Therefore, PTQ must be equal to PT plus TQ. That is to say, PTQ equals in total to PT, that is 2 because it is the radius of this semicircle, plus TQ, that is 1. This is the radius of this semicircle, that is 1. So in total, PQ equals to 2 plus 1, that is 3. PQ equals to 3 units in its length. So those two angles, they are both equal to 90 degrees according to Rule 1. QN is the radius of this circle, that equals to 1. PM is the radius of this circle, that equals to 2. PQ equals to 3. So the only missing side in this polynomial PQ and M is MN. So I put this polynomial PQ and M in a new page. Okay, this is the polynomial PQ and M, that is coming from the original drawing. So the version 4, PQ equals to 3, QN equals to 1, and PM equals to 2. Those two angles are both right angles according to Rule 1. So from point Q we do perpendicular on PM. Again, from point Q we do perpendicular on PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point Q and PM. This point is point L. So by doing this construction, we can detect quadrangular LQ and M. So the other LQ and M, we have 1, 2 further, and therefore this fourth integral must be equal to 90 degrees and inside. According to the rule, it says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth integral must be equal to 90 degrees in size. And therefore quadrilateral LQ and M is right angle because it has 4 right angles. But we also know that the opposite sides of right angle are equal to each other. So right angle NQ and M, side QN must be equal to the opposite side LM. But QN is 1, therefore the opposite side LM must be also equal to 1 unit in itself. What is the for this missing lines when PL equals to PM minus LM. PL equals to PM minus LM. So PL equals to PM that is 2 minus LM that is 1. So in total PL equals to 2 minus 1 that is 1. In the next step, we implemented the Pythagoras theorem on this right grand triangle PLQ. So according to the Pythagoras theorem, this right grand triangle PLQ, PQ squared that is the square of the hypotenuse equals to PL squared plus LQ squared. Again, PQ squared that is the square of the hypotenuse equals to PL squared plus LQ squared. PQ is 3, therefore PQ squared is 3 squared, that is 9, and it is equals to PL squared. PL is 1, therefore PL squared is 1 squared, that is 1, plus LQ squared. LQ is the missing side, so leave it as it is. So in total, 9 equals to 1 plus LQ squared. Here we subtract 1 for this equation, and we know that LQ squared equals to 9 minus 1, that is 8. So here we took out all of this equation, and we know that therefore this LQ is square root of 8. We substitute 8 by 4 times 2, and then the square root of 4 is 2, so inside the root we left only with 2. So in total, we found out actually that LQ equals to 2 times square root of 2 units in itself. LQ and M is a rectangle. We know the opposite sides. We know that the opposite sides of the rectangle are equal to each other. So rectangle LQ and M, side LQ equals to the opposite side MN, but LQ is 2 times square root of 2, therefore the opposite side MN must be also equal to 2 times square root of 2 units in itself. This is 9/7 MN, in total equals to 2 times square root of 2 units in itself. So we define the length of MO as A. MN in total is 2 times square root of 2. MO is A, and therefore ON must be equal to MN minus MO. Yeah. ON must be equal to MN minus MO. So ON equals to MN, that is 2 times square root of 2, minus MO. MO is A. So if you know that ON equals to 2 times square root of 2, minus 1 units in itself. So as I mentioned before, we join points Q and O together by straight line. We join points O and D together by straight line. Point O is the center of the circle. Point is the point of the biggest circle itself. Therefore, O is the radius of the biggest semicircle, that is X. So we implemented the Pythagoras theorem on this right triangle OQE. EOQ. This is EOQ, according to the Pythagoras theorem. EO squared, that is the square of the hypotenuse, equals to EQ squared plus QO squared. Okay, EQ squared, EO squared equals to EQ squared plus QO squared. EQ is X, therefore EQ squared is X squared, and it is equals to EO is X, therefore EO squared is X squared, plus and it is equals to EQ squared. EQ is 1, therefore EQ squared is 1 squared, plus QO squared. QO is one side of this right triangle, but QO is also the hypotenuse of this triangle QON, and therefore it is the square of the hypotenuse of this right triangle QNO must be equal to QN squared plus NO squared. So in total, EO squared equals to X squared, EQ is 1, so EQ squared is 1. EQ squared is 1 squared, that is 1. And QO squared equals to QN squared plus NO squared. For side EQ is the hypotenuse of the small right triangle OQN. Therefore it is equals to UN square plus NO square. So x square equals to 1, and here Qn square. Qn is 1, therefore Qn square is 1 square, this is 1. And we have plus NO square. NO is 2 times square root of 2 minus a, therefore NO square is 2 times square root of 2 minus a square. So in total, we found out that x square equals to 1 plus 1, that is 2. And we have here 2 times square root of 2 minus a square. So open the brackets of this expression. So 2 times square root of 2 minus a square equals to 2 times square root of 2 squared, that is 8, plus a square minus 2 times 2 times square root of 2 minus a. So in total x square equals to 1 plus 1 is 2, and here we have 8, so here we have 2 plus 8 is 10, plus a square, 2 times 2 is 4, so in total this expression equals to 4 times square root of 2 times 8. So in total, according to equation 1, if we found out that x square equals to 10 plus a square minus 4 times square root of 2 times a units in its length. In the next step, we join points O and P together by straight line, and we join points O and C together by straight line. So here we have, according to rule 30, line segment OP bisect chord CD, because DP equals to PC equals to 2. In total, CD equals to 4, and OP bisect CD into 2 halves. The first half PD equals to 2, the second half CP also equals to 2. And therefore, according to rule 30, line segment OP, that is long from the center of the biggest semicircle, also perpendicular, will be also perpendicular to CD. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 30. So in the next step, we implemented the Pythagoras theorem on this right line OPC. Right line OPC, CO squared is the square of the hypotenuse equals to CP squared plus PO squared. And again, the right line OPC, according to the Pythagoras theorem, CO squared is the square of the hypotenuse equals to CP squared plus PO squared. CO is x, therefore CO squared is x squared, and it equals to CP squared. CP is 2, therefore CP squared is 2 squared, that is 4, plus PO squared. So if you found out that x squared equals to 4, and what is the value of PO squared? PO is one side of this right triangle COP, but PO is also the hypotenuse of this right triangle PON. Because of the fact that PO is the hypotenuse of this right triangle PMO, it means that PO square equals to PM square plus MO square. And PO square equals to PM square plus MO square. So if you found out that x square equals to 4, we have PM square plus OM square. PM is 2, therefore PM square is 2 square, that is 4, plus OM square. OM is 8, so OM square is 8 square. So total PM square plus OM square equals to 4 plus 8 square. And PM square plus OM square equals to 4 plus 8 square. So in total, we have found out that x square equals to 4 plus 4, that is 8 plus 8 square. So according to equation 2, x equals to 8 plus 8 square. That is according to equation 2, but according to equation 1, we have already found out that x square equals to 10 plus 8 square was 4 times 2 times 8. So we have two different equations for a square. And therefore we get an equation 3 that states that x square according to equation 1 must be equal to x square according to equation 2. X square according to equation 1 equals to 10 plus a square minus 4 times square root of 2 times a, and it must be equal to x square according to equation 2, then actually 8 plus a square. So in total, according to equation 3, if we found out that 10 plus a square minus 4 times square root of 2 times a equals to 8 plus a square. So here subtract 8 from this equation. If I found out that 8 times 10 is 2, and we have 8 square on both sides of the equation, so 8 square get cancelled. So in this side of the equation, we left only with minus 4 times square root of 2 times 8. 8 minus 8 is 0, so here we left with 0. So in total, if you found out that 2 minus 4 times square root of 2 times 8 equals to 0. So here we added 4 times square root of 2 times 8 to this equation. So we found out that 2 equals to 4 times square root of 2 times 8. Here we divided this equation by 2, and we found out that 2 over 2 is 1 equals to 4 over 2 is 2. So in total this expression equals to 2 times square root of 2 times 8. So 1 equals to 2 times square root of 2 times 8. Here we divided this equation by 2 times square root of 2, and we found out that a equals to 1 over 2 times square root of 2. So according to equation 2, we only found out that x squared equals to 8 plus a squared. So x squared equals to 8. A is 1 over 2 times square root of 2, therefore a squared must be equal to 1 over 2 times square root of 2 squared. 2 times square root of 2 squared is 8. So in total, 8 plus a squared equals to x squared equals to 8 plus 1 over 8. So here multiply 8 by 8 and then divided by 8 in order to overcome factor with this expression. If I found out that x equals to 8 times 8 is 64 divided by 8. 64 plus 1 is 65 over 8. So in total, if I found out that x squared equals to 65 over 8. Our task is to find out the value of this shaded area. From the moment it is very easy to see that the value of this shaded area in total it is equals to the area of the biggest semicircle minus the area of those two smaller semicircles. Again, if you subtract from the area of this biggest semicircle those two areas, you get the shaded area. So if you found out the area of the value of the shaded area equals to the area of the biggest semicircle minus the area of the right semicircle minus the area of the left semicircle. The area of the biggest semicircle, the radius of the semicircle is x. Therefore, the area of the biggest semicircle must be equal to pi x squared over 2. Minus the area of the right semicircle, the radius of the semicircle r is 2. Therefore, the area of the right semicircle must be equal to pi 2 squared over 2. Minus the area of the left semicircle, the radius of the left semicircle is out, therefore the area of the left semicircle must be equal to pi times 1 squared over 2. So here we took pi over 2 as a common factor out of those two expressions, so inside the brackets we left here x squared, and we left with minus 4, and from this expression we left only with 1. So in total, if you found out that the value of the shaded area equals to pi over 2 times x squared minus 4 minus 1. X squared equals to 65 over 8, so we started x squared by 65 over 8. And minus 4 is minus 5, so the value of the shaded area equals to pi over 2 times 65 over 8 minus 5. So here we multiplied minus 5 by 8 and then we divided by 8 in order to come factor with this number. So we have pi over 2 and 65 minus 8. So we multiplied 5 by 8, so minus 5 times 8 is minus 40, and then we divided by 8, so we changed nothing. So in total, if you found out that the value of the shaded area equals to pi over 2 times 65 minus 40 over 8. 65 minus 40 is 25, so over 8. So in total, the value of the shaded area equals to 25 pi over 2 times 16, then 2 times 8, that is 16. So in total, if you found out that the value of this shaded area equals to either 25 pi over 16 square units in size over terms of numbers, the value of this shaded area equals to 4.9 or 0 square units in size. Okay, thank you very much.